Okay, so I need to admit to an obsession. I'm obsessed with the game Captain Toad's Treasure Tracker. I love the vibrant graphics, I love the fact that each level is this kind of isolated world, and I love that it has a unique character controller, and I really want to take that character controller and recreate it in Unreal Engine, which is what I did. And I'm going to explain how I accomplished that. First, though, these are the three components that I think really define the camera system in Captain Toad's. So I've broken down the explanation of my system according to these three components. Oh, before we get into all the details, I do want to mention that this entire project was coded in C++, and all of that code is on my GitHub, so if you just want to go and take a look at that, please go ahead. Okay, let's jump in. This first component was fairly simple. I just used a camera anchor actor that's in the level, and when the game mode starts up, it spawns a new camera, puts it on that actor, and then the character and the controller send inputs to rotate that camera instead of rotating the character. Okay, moving along, we want to be able to constrain or release camera movement. You can see here that the camera's moving along with Toad in the x-axis, but as he kind of wiggles back and forth, there's no camera movement. So we want to add that to our project. And here is our normal camera setup that we had before, but the level's too big. As we move further along the level, the camera is too far away. So we need to enable some kind of movement. The way that I approach this is that we have a data asset on all of the camera anchors that looks like this. So every camera anchor in the level has information that it will pass on to the camera that defines how this camera will behave in game. So you can set how far away the camera is from the character, that's the spring arm length. You're able to set the starting angle, and you're able to constrain various rotation settings, and of course, you're able to allow for X movement, Y movement, Z movement, etc. Everything is data driven and makes this whole system really flexible. For our purposes right now, we're just going to allow for movement in the X axis and save and go back to the game. And there we go. So now we have the camera following along with our character. But again, another problem, how do we get this movement in the Z-axis? We can see that like the level's too tall and it makes the camera a little awkward. So let's see how we actually approach setting this up. On the camera anchor, we have two volumes. So one is this player movement volume. We'll take a look at that. It's basically this giant volume that wraps around the entire level. And then we have a second volume called the camera movement volume. That's this little one here. What we're doing is we're setting the camera's movement based on the relative position of the player inside that larger player movement volume. So if we want the camera to move in the Z-axis, we need to extend this volume in order to allow for a more kind of noticeable movement. And I copy and pasted some values there just to make it quicker, but that's all set up, and then all we need to do is go back into the data asset that is on our camera anchor, and then just check a box. So it's really easy to set up. I really like data driving a lot of these things. And now let's take a look at the effect that it has on gameplay. And yeah, with the character, as they move up, the camera moves up as well, and it stays kind of at a distance from that character. Moving along to the final component, the perspective shifts, I wanted to make sure that I had the option of distinctly changing the perspective of the camera and the behavior of the camera from one setup to the next. And the way I accomplish this in my project is just to have multiple camera anchors. They carry different data assets that define the movement, constrain the movement, and rotation differently from one setup to the next. So when we jump in and play here, this is our normal, can't move the camera, can only rotate. So as we send the character kind of off screen, it's going to hit a collider and we're going to switch perspectives. So this is kind of a top-down feel. And once we hit the collider, we go right back to the initial setup. Let's take a closer look at how this perspective switch is actually accomplished. We have the first camera anchor. It's marked with the default tag, so we know where to spawn our camera to start. It has its own data. It doesn't have any of the movement volumes. It doesn't need that. But critically, it has this trigger volume, so we know when to switch back to it when we move to the top-down perspective. We go to the second anchor, it has different data, it needs the two movement volumes set up, and of course it needs the trigger volume to explain when we should switch to the top-down perspective. That's how this whole system works. that's about it for the main system, but I do want to show off this cool little feature that I added. See, the camera anchors live kind of inside geometry, which normally makes them really hard to see. I solved that by adding this material billboard component. You can see it has its own little material, and if we get rid of that and go back to our scene, the camera anchor is gone. You have no idea that there's a camera anchor because it lives inside geometry, and so we just put that material back, and there it is. So it's easy to spot now. You can't actually click on it, but it just makes the level way easier to read and understand. That's everything. That's how I built the Captain Toad's Treasure Tracker camera system in Unreal Engine. Again, I'll mention this whole project was written in C++. I have all of that code on my GitHub, so if you want to go and take a look at that, please do so. I'm also going to do a little write-up on my website that shows off some snippets of the code. You can go check that out there. But thanks for sticking around for the whole explanation. I hope you enjoyed it. I hope you learned something. I'll see you later.